Hello Year 10s. Hope you'll enjoy the test today. What we're going to look at in this video is sketching quadratics using our CAS given the equation. So just recapping from Year 9, there are some key features of quadratic, and when you're asked to sketch a quadratic graph, you're essentially asked to plot these key features, then draw a nice smooth curve between them. The key features being the x-axis intercepts. Recalling there might not be two, your graph might look like that, or like that where it touches, so they aren't necessarily complete. Alternative, and after you've plotted the x-axis intercepts, y-axis intercept there, and turning point. One other feature that isn't on here, but you should be aware of, is the axis of symmetry, which is the vertical line straight through the turning point, in the form x equals something. Now, in this topic, you'll be expected to, when you're given a graph that looks like this one on the right, tell me what equation made that graph. But what we're going to look at today is, given the equation, how to find the key features using the CAS. So, quick recap on how to use the CAS, or in fact teaching you how to use the CAS, because I'm aware not many of you have used it before in detail. So, in the CAS, many of you will have used Scratchpad, the one on the left. If you open up, it just works into an ordinary calculating space, which is fine, except if you want to do multiple problems through an assignment or a test, you can't then go back to what you've done previously because it's been deleted within the Scratchpad. So a better way to do it is to click New Document, and then you have a whole list of options. The two you'll use most often this year are calculator and graphs. Let's start off with calculator. Ordinary calculator page. 3 plus 4 is 7. Easy enough. Now, lots of the hotkeys that work on the calculator also work on the computer also work on the calculator. So Control-C, Control-V, Control-Z, that all works. If you want to insert a new page, Control-I will put a new page within the same document. And note up here, I can toggle from one to the next. Now, what's really cool about this is that any variables I define in one of them, say for example, I could say n is going to be 5, store n as 5. Well, that's embarrassing. Why is that not working? Apologies, I got the wrong way around. You want n5 to be stored as n. That means I've then defined n to be 5. So I could write 4 plus n, and 9. Easy enough. That then carries across to the graph. If I wanted to plot n, you see how n is in bold? That means that it recognizes that n is something special. If I wrote n at another letter, you see how a doesn't come up as bold because I haven't defined a to be anything yet. And that is the line, well, y equals 5 effectively. Now, if I go Control-I, I can add as many pages as I want here. And each time n will come across to all of them. However, if I want to move on to a new problem in a test, I can go Document here, Insert, Problem. Note how at the top, instead of going 1.2, 1.3, it's now gone 2.1. And now n doesn't hold its meaning. The variables, everything you've defined previously, doesn't carry across the new ones. Cool, huh? Now, a few things you might want to be able to look at is, in Documents, you can go down to, note how my buttons go red so you can see which ones I'm pressing. Go down to Document Settings. Float 12, that's the number of decimal places you'll go out to. Angle, we're using degrees in Year 10. If you're in Year 11, you'll use radians. You'll never use the other option, gradians. Exponential format, those two you want to leave. Calculation mode, you may want to change. Auto, the calculator will decide whether the answer is simple enough to give it to you as exact. So if the answer was a third, it would give you the answer as 1 on 3. If you chose exact, the calculator will always give you an answer of either a square root or a fraction, but they might be hideously complicated fractions when really a decimal would be more useful. If you ask for approximate and the answer is a third, it will give it to you as a decimal approximate no matter how simple the fraction is. So auto is a good one to leave it on, as are all the others. Alright, so graphing. Just deleting a few things, Control-Z, delete. Now, to graph, first of all, we would want to be able to set our axes. So from -10 to 10 is the default, same with -6 2/3 to 6 2/3. If you ever want to change them, easiest way to do it is double click, and it highlights that. And then you can say 12. And if you press tab, you go around the others as well. So you could go 12, 12, -12, -5 to adjust your axes to zoom in where you'd like. Alright, now let's graph the one I'm after. So the one we're looking at is 2x squared plus 12x plus 18. So entering graphs, a couple of ways you can do it. You can either double click. Now that looks slightly confusing because instead of y, where we want to see a y, there's f1 of x. That's function notation, which we don't get to do this year. You can just treat it in your head as y. If you don't like doing that, that's fine. You can go menu, graph entry, and edit equation. Now from equation, we want either a line. So using equations of lines, you could go y equals mx plus b, x equals c for a vertical line, or into the standard line form. But perhaps for quadratics, you want to enter as a parabola, which is the number 2 option. Now, vertex form, standard form, apologies, you'll be quite used to going between those two forms by the end of this topic, but standard form is the one that our question's in, so we'll click that. And note how it brings up y equals and throws in our x coefficients already, or it becomes fill in the blank. So remember, for us it was 2, 12, 18, 2, tab, 12, tab, 18. Enter. Now, we need to adjust our axes because it doesn't fit in there. This will need to double click, we'll go to at least -10 there. We'll go to at least 20 there, or might even go more than 20. Let's go 25. And we're starting to see a bigger picture. Now, if you hold your cursor over it, you can move things. Careful, if you click and move that, it will adjust the quadratic, which is cool because you can watch the equation being adjusted, but it doesn't really help us with the current problem if we're trying to find the x and y intercepts of that. So Control Z and it'll bring us back to normal. Now, let's find the x-intercept. We can probably see, well, there it is. It's not hard. It's going to be, what, -3. But to check that, you can go Menu, Analyze Graph, Zeros. Zeros is where the graph crosses the x-axis. And then it asks for lower bound and upper bound, basically saying, where should I look for the zeros? And this is because some graphs cross the x-axis an infinite number of times, and we might only want where they're crossing in between certain portions. So there and there, the 0 is at -3. No surprise. Menu, Analyze Graph. We want to find the y-intercept. Sorry, no we don't. We want to find the minimum. Now clearly the minimum is going to be on the x-axis, but this would work as well if it wasn't on the x-axis. So we go minimum, there and there, just highlights the same point. Sorry, quite a poor example in hindsight. Wait, we can just do this, can't we? Come off. Alright, sorry, that little experiment failed. Anyway, the video's gone for quite long enough. Hopefully that gives you a brief introduction on how to use your calculator to graph graphs and find key features. On your OneNote, could you please sketch the key features of that graph using your CAS? Thank you very much, and I'll see you next lesson. Bye.